So I am very happy right now. I finally get to talk at the UrbanSim users meeting. I've been waiting for this moment for like a day and a half now. So great. Yeah, so you've been hearing a lot about Synthicity, about UrbanCanvas. You saw some very cool demos by Connor, Fletcher, and Eddie yesterday afternoon. You heard Kendra this morning talking about how they've been starting to use UrbanCanvas. And I talked to Fede, and I say, well, we're kind of leading the C++ development team in Synthicity. Why don't we put a talk together about what's the magic sauce underneath, if you will, and how we're making all this technology happen. And we've been working on this for the last 9 or 10 months or so, and so it's a very exciting moment for us to be finally able to share some of this technology with you. So let me first talk a little bit about our motivation to create UrbanCanvas. We have been wanting to work on a new 3D visualization platform for quite a while. And the reason for wanting a new platform and something that is 3D is pretty simple. A flat world is a very dangerous place. So we have to go to 3 dimensions. So that was a must. And we also wanted to create a tool that was customized for urban applications, because that's our area. That's the area that Paul has been working on for quite a few years now, and it's a very exciting field to be part of. So we believe that the problems in urban planning, urban design, and all the derived areas are complex enough to deserve its own dedicated software tools, and that's what we want to build. So to introduce an analogy here, our belief is that as planners, as modelers, you should not be asked to use a generic geographic tool to solve your very complex and challenging problems just because that tool happens to handle shapes, any more than a graphics designer should be asked to use Paint to do advanced photo editing just because Paint can handle pixels. So we really want you to have a customized tool set that is built with your needs and problems in mind. So another thing that we thought when we were deciding to create UrbanCanvas was that we wanted to build something from scratch, and the reason is that there has been, you can imagine how much advancement there has been in hardware and software and software libraries and so on in the last years, and we just want to be able to take advantage of the state-of-the-art hardware and software libraries. So again, I kind of like analogies. Just imagine if they had built Tesla by adding patches and incremental improvements to a Volkswagen Beetle. That would not have been a very good vehicle. So, what we want to do is to start from scratch, take advantage of the new stuff, and yeah, you get the picture. And I want to clarify here that, I want to be very careful with what I'm saying. None of this is actually done already, so don't expect that we're going to show you a tool that where we have solved all these problems. But I do want to make it clear that this is our motivation every day when we plan the next iteration of UrbanCanvas and of our software. We're keeping these goals in mind. So a little bit more about UrbanCanvas. There are 3 characteristics that we have in mind when we design this solution. So the rest of this talk is going to go circle around these 3 characteristics. The first one is that we want it to be fast. And we want it to be fast in terms of how fast you can load data, how fast you do computations, how fast you do navigation in a 3D world, and how fast is your design pipeline, and so on. So Fletcher said yesterday that as a software engineer, he's very impatient, and that makes him a good software engineer. That applies across the board. We're all very impatient. We don't like waiting not even for a second for a result to come back. So that's a high priority for us. So we also want UrbanCanvas to be flexible. And when I say flexible, I'm referring to interoperability, cross-platform support, connectivity to web services, and so on. And we'll talk a little bit more about that. And finally, we want UrbanCanvas to be informative. And this means that we want to support urban assets that are queryable. We want to support interactive visualizations and very expressive visualizations, and we want to go beyond spatial dimensions. And we're also going to cover this in a little more detail now. All right. So for the rest of this talk, the topic is going to be the following. first, we're going to tell you how we are doing this, what are the technologies behind it, how are we trying to achieve these results, and also what are the advantages for users that we expect that users will get by having this technology available. All right, so Fed is going to start telling you a little bit about how we're making UrbanCanvas fast, or trying to make it fast.
Yeah, so the first point is that in the last decade the computer processors were evolving, but I mean not in the individual performance of one single thread, but trying to do many things at the same time. So we now have in any computer multiple cores, and we need to take advantage of that. So in any UrbanCanvas run, you will have around 50 to 70 threads running. Many of them are related to data retrieving, and some of them are related to rendering and also the UI computations. So, for instance, regarding related to the examples or the demos that we showed yesterday, when we were transferring data from UrbanSim as indicators to UrbanCanvas, many things were happening with different threads. Some of them were downloading information from a web service, and we do that multi-threading. I mean, we separate the extent that we are visualizing in different tiles, different parts, and we launch different threads to download part of that extent. And of course, there are other threads doing the drawing, converting for the geometry layers, converting the geometry in actual 3D objects, and many more things. Perhaps I'm explaining too much. But the idea is that we give a general overview, and if there are questions or we want to know, more about a specific subject, we can do that. So I think that's enough about multi-threading. Yeah. So the results for the end user is that you don't have to wait. I mean, we prioritize the threads to first load the information that it's closer to the camera. So we start from the center of the camera, and then while you're starting to visualize and analyze the data, other background threads are loading buffers around the part of the screen that you're viewing, and then you don't have to wait. I think that's the message. Yeah. Other important point is that I think it's also a trend these days is cloud storage and computing. About storage, we are retrieving data from a lot of different sources. Most of them are cloud-based, are from the internet. One example are the different map tiles that we are retrieving. We support a lot of standards to be able to communicate to very different services, providing different information. And that is great because it's very easy to add more information and custom information that a customer could have. We also have a local cache because sometimes it's expensive to go to the to the service that provides the information. So we cache locally, taking into account the time that when we retrieve information and comparing that to see if there are new versions. And that is also I discovered the other day because I had an internet shortage at home, and I wanted to test some features and keep programming. And this is an application that depends a lot on having the network. But that day I discovered that I can just use the cache. I mean, if I don't have internet connection, at that point I had the 600K parcels of Mr. Code loaded, and I was testing with that region in particular. So I was able to keep working with the local cache it is, of course, faster than retrieving from the database. And it is also multi-threaded because, I mean, the threads first try to go to the cache, and if the information is not there, we go to the network. But, I mean, the cache retrieval is also multi-threaded.
Just in case, the cache is just a local copy of the data that is saved in your hard drive automatically. And when you go to a new location, if the data, we first check that the data is in the hard drive. If it is, we pull it from there because it's not much faster. And if it's not, then we go to the remote server and download it from the server and then bring it to the cache. So that just speeds things up. It's all about, doing it fast.
Yeah, right. Please let me know if I am, using some computer science words that perhaps are not easy to understand. The cache, I thought that is something that is known mostly because the web browsers
same thing,
use a local cache, so many people are familiar. But who knows? And the other important thing regarding this point is using for some resource-intensive tasks using the server power, not using the client. We have many things to do in the client that are more related to retrieving data and rendering. Converting also the geometry from the source format that can be WCAP view or something like that to 3D objects. So we want the heavy algorithms to be on the server because it's closer to information, and usually there are more computing power on the server than on the client.
Yeah, and that way we can also reduce the technical requirements on your client laptop, so you can actually use a lot of this heavy computation even from a low-end computer. That's the plan, at least. That's what we've been trying to do so far.
Yeah, and this have like a side effect that is that it's very easy to implement and deploy UrbanCanvas in a new computer because you just insert the package that has all the new libraries, and then the data is retrieved from the server, and then you build your local cache, so you improve the speed. But it's very easy to, you don't have to copy a very big file or something like that. Of course, you have the ability because, as we have seen, we can use a NumPy, for example, arrays, and if you want to copy a NumPy array and have it locally, you can do that. But if not, everything can be retrieved from the network.
So you can set up a local database and do it all from there as you would in more traditional workflow, or you can just, as Fede said, download the installer, install the application, and start fetching information from a remote server. All right, so I'm going to tell you a little bit about interactive rendering and navigation, and that's something that we also pay a lot of attention to in order to make UrbanCanvas very fast in rendering. So you saw yesterday, if you've used more, mainstream and traditional tools, I'm not an advanced GIS user by any means, but I've heard that sometimes you will, pan around, zoom in, and zoom out, and the refresh rate is not ideal. You might have to wait for seconds or minutes sometimes to be able to refresh all this. We have a very simple rule: if it's not rendering at more than 30 frames per second, it's not interactive. We don't want it to refresh every 5 seconds, every 10 seconds. You cannot see the delay between one frame and the other. Otherwise, it's not interactive. And there's a lot of work to make that happen. The reason is that we're rendering a lot of data. Now, we represent 3D models with triangles. Everyone does. That's how graphics cards store 3D models. And when you're looking at, this is again going back to Mr. Cog, this is the Albuquerque region. It's hundreds of thousands of parcels, and you will map that when you are rendering also streets and buildings and zones and development projects and so on. This maps to tens of millions of triangles that you have to render. So this is the whole region. And if I zoom in and give you a little more detail of what's happening underneath, that's what it looks like. This is the wireframe. These are all the edges of all the triangles that we're rendering for a relatively small area of Albuquerque. So what happens is that in the graphics card, you have a representation of the triangles in a 3D world. But then what the graphics pipeline does is to translate those triangles into a map of pixels. So what is in your screen? You have 1800 by 1200 pixels. You need to determine what the color of each of those pixels is, and that color is given by whatever geometry is being pointed at by the ray that passes from the camera that passes through that pixel, and that's rendering. When people talk about rendering, that's what rendering is: going from a 3D geometry in your graphics card to a map of pixels that is projected onto your screen, right? And we do that not just at 30 frames per second, but we actually want more like 50 or 60 frames per second, and you're handling again tens of millions of triangles at the same time. So we've exploited advanced computer graphics libraries, and not only the libraries but also the hardware to make that happen. We store very efficiently the geometry in the graphics card. We also do very efficient handling and communication of geometric data between the main memory and the graphics card. And I gotta tell you, it's a big effort to keep this synchronization of memory between the main memory of the computer and the GPU, but it's totally worth it. You know why? Because if we didn't do this, then you would have to wait for 5 seconds or 10 seconds or 2 minutes for a frame to be updated. So we give a lot of, we take this very seriously. All right, so this is a result. The advantage to users is that you can navigate in a virtual 3D world with millions of parcels, buildings, and roads at 30 plus frames per second. And this is a live capture. This video is actually in our website. I didn't create a new video, so I'm sorry if you've seen this before. But this shows how fast we can pan around a city at, again, more than 30 frames per second with very massive geometry.
Yeah, in this scene, I think we are like close to 50 million triangles.
Yeah. All right. So one more thing about UrbanCanvas being fast is we have done quite a bit of work in supporting both interactive, manual, and procedural asset editing. So this is a big thing. This is what or part of what my PhD thesis was about. How do you create 3D assets procedurally following rules? This is what City Engine does, and they're really good at it. And I help them build a little bit of this when I work with them. And it's a very exciting world. And we want that technology to be part of UrbanCanvas, and it is part of UrbanCanvas. So we have built-in support for manual editing of buildings and parcels, and Rob is going to show a little more about that in his talk later today. And we also have shape grammars, and we built our own fast shape grammar parser for 3D building and road generation. So a grammar is just a set of rules that are followed by the computer to create a 3D model. So it allows you for a very compact parametric representation of a geometry that you can replicate throughout the thousands of parcels of your city, and you can create a very complex and highly detailed city in, again, under a fraction of a second. So advantages to users, well, you can modify 3D assets in the same environment where you are running analytics and visualizing data. We believe that this integration, being able to do all of this in the same place is very important. We don't want you to be switching back and forth between 5 different applications. So that integration aspect is key. And you can also create detailed and data-driven 3D assets using state-of-the-art procedural technology. And here's a quick video showing that. So, by the way, I have to do a disclaimer here because I'm talking to planners and modelers. This is not happening. This is a mock-up example that I did just to show the power of this technology near the Caltrain station in San Francisco. This is not an actual development project, so please don't be alarmed by it. But yeah, let me show a little bit. So we're just flying in the city. We have this near-far realistic representation, and all these buildings are actually procedural. They're not manually made. So they're what some people would call geotypical buildings for a location. So we choose a development type, and think of the development type as a paintbrush style. Take that paintbrush and start painting things around. So you click on that parcel, and that's going to paint a building with these characteristics, and you're not doing any manual modeling. This is all procedural technology. So all the facades, the roofs, the details of the building are being generated procedurally on the fly, and you can do that either at a small scale or at a large scale. And we believe that this is a very powerful editing tool that might find a lot of applications, especially in greenfield and brownfield development or design. So just to give you an idea about the kind of things that we're working on. Again, imagine how long it would take every time you click there and change the height of a building if you had to go to AutoCAD or one of the standard 3D software packages and manually model each one of these entities. So it's very exciting stuff. All right, I'm going to turn it over to Fede, who will tell you about how we're making UrbanCanvas flexible.
Yeah, so first point is that UrbanCanvas is multi-platform, so we are currently supporting Mac and Windows. We plan to generate a Linux build soon. Some people asked during the user meeting. And we also have been experimenting with tablets, especially with the iPad and iOS. And I think we had good results, but still, I mean, we didn't have the time to finally start supporting it like, one more platform more, because that involves a lot of work. The other point is that we can go to different scales with UrbanCanvas. At some point, we had some discussions regarding, if it is a good idea to have just one piece of software for regional uses and very local usage. But we find out that, using some techniques in the software, it's possible to have, share the same virtual world for the different scales, and that works. It's just, a matter of using the right projections, geographic projections, and it works, and having different level of details, some techniques that allow us to finally.
You also need to be very careful on how you handle floating point precision in memory, because you will know that a number in a computer is represented with a finite number of bits, and the problem is that when you want to represent something as accurate as an inch or a centimeter, and you also want to represent miles, and in the same floating number or double floating precision number, then you need to be clever about what part of the bits you want to use to represent each scale. So we did quite a bit of work on that, but it's possible. You just have to kind of make sure that you have a dynamic origin for your coordinate system, so that when you're representing things that are small, you're very close to let's say the zero in your floating point representation. So it gets a little technical, and it gave us a few headaches, but it seems to be working.
Yeah, right. You will see a presentation, I think, after us that probably about local scale applications.
So here's a regional scale. This is a million parcels in New York City. There's a more neighborhood scale, area site scale, and then you can go down to actually the building scale and the floor scale, which, as Fede says, Rob will demo later.
Yeah. So one ring to room the door. Okay. So going on with flexibility in UrbanCanvas, we can connect to many sources, as I told you before. We have seen the demos yesterday, this demo, Fletcher's demo. We can connect to Python. We can connect to Pandas web services. And we can also read NumPy arrays and use that for colorizing different indicators. And that opens, a lot of applications, because there are many web services on the web. Not only this Pandas web service that we are currently using, but the web is full of web services, and if you have your own, we can connect with UrbanCanvas. And then I will talk a bit about formats. We can read shape files, PostGIS tables. That is right now like our main source of information, and also OBJ files, not only from the local file system, but also downloading via HTTP. So we'll read the bundle of the OBJ file and also the textures, and we can we can position the model in some place. We use that for landmark buildings, but there are many other applications. I am used to code the backend, so I think on more on the capabilities that it can be applied to a specific usage, but I think more on having the backend, general, the general ability to load things, and then someone will figure out how to apply that to real uses. And in the output, we can write to PostGIS. That's the way that we edit data right now. And we are also writing transactions to PostGIS, not only information. You go and change the height of a building, for example. We are not only storing the information of the stories that change, but also storing the transactions, because we want to be able to track the changes, in the time. So we store the user that did the modification and also the date. So it's possible for a particular object, that can be a building, a parcel, or something else. We can have the history of changes. And we can also export to GeoJSON. That is again JSON, the JSON format, but this is geospatial extensions that allow you to store in JSON polygons and any kind of shapes. And we can also export scenes to WebGL. I think we'll show very.
So here's just an example of how we can bring handmade geometry, like Transamerican Pyramid in San Francisco, and insert it into the models. How we can bring PostGIS or shapefile data, and really any type of polygon data that you have available for your region can be imported. So in this case, we're showing blocks, parcels, and zones for again for Albuquerque, just as a little demo. Okay. And
let's go fast for this because we might run out of time.
We're getting too excited about this, and we need to move forward.
So this is an scene, I think, from the Bay Area that we exported using the UrbanCanvas exported to WebGL. I don't know if you know what is WebGL, but it's basically 3D on the web. Perhaps some of you have seen the newest version of Google Maps that allows you to see buildings, 3D buildings on the web. So this is the same, and S3 also, I think, has something about this. We are exporting the geometry to a web URL that you can share for engagement. It's very easy to do this in UrbanCanvas.
So this is just a prototype where all the buildings are white. We can export the buildings with textures and colors and anything that you want to share with whoever you want to share the
but
the
the geometry is there. And this is another example that we did using WebGL on the web. That is what you see on your left is the text that represents an instance of the grammar that Carlos described for procedural generation. And this is a web application, so it's accessible on the web. And you can see that Carlos is changing some parameters in the grammar, in the source file of the grammar, and you see the building changing. The important part of this is that this is like the resite to construct a building with rules. It's not like the actual building. So if you use as the input data a different parcel, the building will adapt to that parcel, or modify also the height of the building, the height of the floors, many parameters, and the building will adapt to the parcel. So I think we'll show the video of grammar geometry
Well, this is what is behind the video I showed earlier in the Caltrain station in San Francisco. We have many buildings being generated from a set of these shape grammars, which can be thought of as the DNA of the building, and you can use it to generate many of them.
Yeah, right. Okay, so yes, we can import existing data. UrbanCanvas is an open application regarding geographic formats. Yeah, so you have seen probably a lot of things yesterday in the demos, edits and Fletchers, but we want to emphasize that there is a seamless connection to UrbanSim. It's possible to retrieve indicators, to export geometry from UrbanSim, to use the development projects that we create in UrbanCanvas as planned developments in UrbanSim. And I mean, everything is connected. We know both platforms very well.
All right, so that was a quick overview of how we're doing to make what we're doing to make UrbanCanvas fast and flexible. And now I'm going to tell you a little bit about what we have in mind when we say we want UrbanCanvas to be informative. So one thing is that we want the assets in the urban models to be queryable. Can't say that word right. But what this means essentially is that the 2D and 3D geometry is not just polygons or triangles. They're actually assets with a semantic meaning, and we are able to query those assets, to measure them, to deem them in different ways. And this will be covered in a bit more detail in Rob's and Jason's talk later in this session. Also, one way to make UrbanCanvas informative is to support non-spatial dimensions, and you already saw a little bit of this yesterday. I just want to remind it briefly. We see UrbanCanvas as not as a 3D canvas, but actually more as a 5D canvas. You're navigating a 5-dimensional space, if you allow me to use that number. You have the three spatial dimensions, and then on top of that you add the time dimension, and you also add the scenario dimension. So when I move the mouse around and navigate, I'm moving in that in 3 of those 5 dimensions. Then if I go ahead and move the time slider, I'm actually moving in the 4th dimension and changing the city in time. A city is not static. We wouldn't have jobs if they were, and so we want to be able to navigate in that 4th dimension as well. And same for scenarios. You showed yesterday how you can switch back and forth between different scenarios, and that's what we consider to be the 5th dimension. So we had to customize our backend data structures to support all these, and being able to change the visualizations very quickly for these cases. Also, a way to make it informative is by supporting 3D terrain. This was very important. If we don't, if we agree that it's dangerous to live in a flat world, then we definitely need to be able to represent terrain. So what we did so far was to get elevation data, digital elevation models for all of the U.S. And so we have national coverage at this point. We created our own tile server for elevation data, so that again, you don't need to install any local data. You just download UrbanCanvas, and the elevation data is fetched and rendered in the application. And we also had to support multi-resolution and level of detail to be able to render terrain in more detailed way as you get closer to it. So here's a flyover some of the hills in San Francisco. This adds a lot of realism. We're really happy that we can have this kind of terrain representation in UrbanCanvas. And when you combine terrain with high-resolution aerial imagery and procedural buildings, you're starting to get very close to photorealism, and we like that. All right, and I won't go here into too much detail because Jason will also mention this, but we were putting a bit of thought into interactive theming. Essentially, we want to provide an expressive and intuitive approach to specify connections between data and visualizations. This is what this software is mostly about. You have data on one side, 3D stuff and 2D stuff on the other side to visualize your data. And we want to make sure that the way you're connecting your data to the visualization is very intuitive and easy to understand and to specify. So this is just a representation. You have data on your left, and then we support a few kinds of 2D and 3D charts, like pie charts and 3D bars and extrusions of arbitrary geometries. But then what we really care about at this point is that it's easy for you to tell UrbanCanvas how you want to map your data to different visualization styles. And you can even make New York look like Easter all the time if you want. All right, so that was a quick overview of UrbanCanvas, what has been keeping us busy. I'm going to try to wrap up quickly so that I hand it over to Jason. But before I go to the summary, I just want to acknowledge all the contributions that have been made by the rest of the development team, C++ development team in Argentina. So that's Juan on the left. He's a pretty clever guy when he's not drinking beer, and a freaking genius when he is. And then there's Dario on the right, who is he's also made very important contributions to some of the stuff that we just showed you. And I added the Argentinian soccer jersey there as a big cliche. Turns out both of these guys hate soccer, so I'm kind of annoying them with this. We're not getting more people from Argentina if they don't like soccer. So, all right, so as a summary, we have just presented a really quick overview of the technology, behind the scenes technology in UrbanCanvas. We try to show you what we're doing to make it fast, flexible, and informative. There's a long road ahead, long road ahead in terms of adding features, better integrating with, mainstream or standard workflows, supporting more types of data. But we've made a lot of progress so far, and it's been only about 10 months of development in a team of 3 or 4 people on average. And here's my proof that we have made a lot of progress in the last month. So if I had given this talk to you in October 2012, this would have been my only screenshot of UrbanCanvas. So that was UrbanCanvas version -1, literally 9 or 10 months ago. And this is where it was when we were just doing initial testing and determining what technologies and what libraries and what platform we were going to use and so on. So I'm very glad that this is not what I'm showing you today. All right. I also have to say that this has been extremely fun to build. It's been a privilege to work next to the rest of the team at Synthicity, which you have already met. It's been a lot of fun, and I cannot thank Paul enough for his efforts to convince us all to get together and build this thing. Where I spent quite a few years in academia, and I enjoyed it a lot. But I have to say I'm very happy to be working on products that we expect to have a lot of impact in real world problems, and I love that. We all have a great time when building this stuff. And finally, and most importantly, I want to make it very clear that we are building this for you. I mean, when we are planning the next iteration of UrbanCanvas, when we're thinking about features, when we just want to make your lives and your everyday work easier. And so the bottom line is that we really want your feedback for this. I would like to persuade you to look at Synthicity as a growing but small enough company that we can actually listen to what you're saying. Like, our business cards don't have the office number; they have our cell phone's number. So if you call the number on my business card, I will pick up and you can tell me we want this feature. And I'll be like, okay, let me convince the rest of the team. But really, talk to us. We're building this for you. So I think that's about it, and we'll be very happy to take any questions you have at this point.
Thank you. So we're going to talk about the interface design, and yes, this is the graphical user interface. I'm a designer. I like graphical user interfaces. Apologies to Fletcher. So we've heard a lot about what happens in the really cool 3D colored part of the screen in UrbanCanvas. Now we're going to hear about what happens in the really boring gray part of the screen over here and over here. But it's really your dashboard to what's happening underneath. So now I want to talk about our goals with interface design, the strategy we're looking at, and get your input on it. So, tagline for UrbanCanvas is explore massive urban data sets. And really, that's exploring the data sets as you're working and you're modeling, but it's also to facilitate communication. And the strategy that we're undertaking for that is we want something that's flexible. There's a lot of different tasks you undertake when you're working with this kind of data set. But it also has to be focused so that you're not distracted by interface elements that aren't appropriate at a particular time. And customizable. A lot of different potential uses of this tool, and we want to make sure that it's laser focused for what you need it to do. So some of the things that we know that people want to use UrbanCanvas for and are using it for are tabular data editing, interactive theming of data is something we're working on now. We want to set up cameras and layer configurations and view configurations that if you do see something, well, when you see something you like in your visualization, you can save it and export it and share it and easily bring it back when you're presenting to other people. And porting evolving and porting the features that we have in the initial versions of UrbanCanvas into the next generation, such as tracking development projects. That's a lot of stuff, and we want to make sure that we can attack one of those at a time and add things incrementally and modularly. So we want to be focused and expose these things one at a time. And as I said, we want it to be customizable because sometimes you're going to be creating visualizations and sometimes you're going to be sharing them. The approach that we're taking is a workspace-based approach. So I'll show you what I mean by that. And we've been looking at the current generation of the interface and all the other presentations so far. This is a rough prototype of the next generation where we've tightened up a lot of the space around elements and we've grouped things, and on the big screen it's kind of hard to read the small text, but on the desktop it's much nicer. So the workspace control is in the upper right, and that lets you pick what combination of tools you're looking at a specific time. So you might have design tools where you have a palette of attributes, say land use, and you choose the one that you want. You would pick a paintbrush, and because this is a mock-up, I'll let you use your imagination. I'll click on things and the color changes. You might have some simulation parameters that you want to enter in an interface that would have a different set of panels, we're calling them, as the separate windows within the workspace. You might be editing scenarios, or you might be controlling how the data is themed. So you might also want everything to go away and just show the results to other people. So you can do a full screen. A little bit more on theming. Carlos mentioned this briefly, but we're putting a lot of attention into this right now because this is a really essential feature, is connecting your source data to the target visualization. And you have to have some means of translating between the two and specifying those parameters that translate from data to visualization. So simplest level, you have numbers, you want to make them into colors, and unit conversion function. So this is an even rougher mock-up that's just basically a sketch, but we're showing the basic components of a theme editor that will work its way into UrbanCanvas soon. So fundamentally, we have a list of themes that are appropriate for a particular layer in the 3D visualization, which you can add, delete, and edit. So you click the gear, you get different settings available. Very standard GIS stuff, but we're trying to keep it as clean as possible and interactive. You pick the type of visualization, so you might be wanting to color shapes and geographies. You might want to have a bar chart that's based on a particular data point. And sometimes it might be even more straightforward than that, and you want to have parcels have a black outline. So the source data there would be a constant. So the fundamentals are what kind of data do you have that you want to connect to a specific attribute. Here we're working on fill color. So we're going to say it's going to be based on a field. That field is the zoning ID, and it's based on a color map that is specified as a series of colors that equal or equate to a particular ID. Now, other typical mappings are minimum and maximum values to colors in something like an FAR visualization, or you might want to specify the specific breaks between different colors in a population visualization, say. Let's look a little bit more at the different types of themes. background images, as we said, we can attach to a host of different kinds of web services, so you might just want to specify a URL in that case. You might have, like we were just looking at, ability to color different types of geography based on a constant, a field, an indicator, like Eddie was showing yesterday, but you'd be able to access it here instead of going through the IPython interface. Take your pick. And to your question, we will save the configured views in worksheets, which will work a lot like Excel tabs, where you pick at the bottom of the screen which one of your saved views from a prior work session you want to restore. You can add a new one. And these will, of course, just be snapshots of camera position and a set of indicators or layer visibility settings, but you'll still be able to rotate and zoom, but this will just bring you back to that point. So very useful for stakeholder settings. And again, we're looking at how these different workspaces get packaged into versions for different users, and different users working at different times. So sometimes you're an author, sometimes people are viewing. Could be the modeler, it could be someone doing sketch planning, area planning, policymakers taking a look at the information, public engagement, or other stakeholders. So like Carlos said, we have a lot of ideas on the table. Our hardest task right now is choosing what to do next, and we want to do what you need. So definitely get in touch with us, and hopefully at the end of the day, in Paul's talk, have an opportunity to engage and let us know what's up. So pass it on to Rob, who's going to talk about using this for smaller scale planning.
Okay, so my name is Rob Matthews, and one of my roles at Synthicity is to deliver really exceptional user experiences, and many of the people on the team are very dedicated to that as well. My background is in urban design, planning, and real estate, and I have been involved as a professional consultant in that realm for many years. And I've always brought a sort of a tech-heavy focus to what I was doing to help try to create innovative solutions. So as you can imagine, it's really exciting to be a part of this team and to be helping to deliver this next-generation technology to you, our current and hopefully future users. So what I'm going to be talking about today is, let me just switch around here. Is a little bit about area planning and urban design. So this is where we're going to start getting into some of the building level details that some of you have been talking about, like mixed use and things like that. And hopefully you'll see some things that you like. And also, like everyone else has said this afternoon, we're very keen on getting feedback from you. So afterward, if you just want to pull one of us aside or email or call, we really want to hear from you. So since you're all, almost all of you are heavily involved with regional modeling, I certainly don't need to go into any of the details about that. But you're clearly working with a lot of information, and whether it's regional control totals or long-range transportation and land use planning and whatnot. So what I want to do is kind of start at that level and then start bringing it back down scale by scale until we get into the really nitty-gritty details that exist at the site level or the project level. So the next step down from that would be something like a station area or a transit corridor, rather multiple station areas. So I mean, this doesn't need to be transit focused, but what I'm going to be doing in this demonstration today is looking at data that were and information that comes from the PSRC area and the Seattle area, and specifically the Link Light Rail. So here you see a piece of the Link Light Rail that's in southeast Seattle with some station area locations. This is a built and operating light rail system. But much of the land along the light rail itself remains underdeveloped. So I'm going to get into some of the implementation level details about that stuff. So as you can imagine, when we think about regional planning and then the transition of that into what is required to make comprehensive plan changes, zoning changes, and whatnot, and ultimately do implementation at this scale, it's really where the rubber meets the road. So if the implementation doesn't go as planned or doesn't go the direction that was consistent with the regional planning, then ultimately these goals are not achieved. So what we want to do is to help leverage the technology that we're creating across these scales to help close that loop of understanding the inputs that come from regional models, and then understanding what that looks like, where the rubber meets the road at the implementation plan at the site level, and then use that information to feed back ultimately into the urban simulation model. So a good example of this is, we're obviously focusing on the intensification of land uses around transit and TOD, for example. So will the heavy lifting of upzoning and making all the changes that are happening along the TOD and along a rail line actually do the heavy lifting that is required to help us achieve things like reductions in greenhouse gas emissions? So some other benefits of looking at the connection between regional scale and the local scale is that information can be exchanged easily amongst members of a COG, that you can look at a regional development pipeline and really get into the nitty-gritty details of what an individual project looks like, and I'll show that in just a second. And then ultimately, there's an opportunity here to help provide consistency with the implementation at both scales. So now I'm going to drill down another couple of scales here, looking at sub-areas. And sub-areas go by many names. This could be a station area, it could be a neighborhood, a district, or a campus. All of those things are fair game for this scale, or a specifically defined project area. In this case, it is the Othello station for the Link Light Rail in Southeast Seattle. So some of the policy options that using a tool at this scale will allow you as users to explore, and leveraging some of the technologies that you saw earlier in our labs previews with painting, zoning, and using procedural generation of buildings and whatnot, are things like looking at and exploring current development and what the trends might look like and what different scenarios might look like from the regional scale modeling. They also could be site-level alternatives, so just another use of scenarios. One thing that's really important is understanding what development capacity is based on zoning, overlays, and other kinds of regulatory structures. And then painting and thinking about what-if scenarios around future changes to comprehensive plans and zoning. There's a lot of complexity that creeps in when you start dealing with floor area ratio bonuses and such for affordable housing, or in Seattle there's a green factor that attempts to make buildings more environmentally sustainable. And those things can become kind of overwhelming from just a tracking standpoint. So when you have digital tools like this that do all the math for you, then it becomes easier to focus on the policy outcomes. Another aspect that is increasing in certain regions is transfer of development rights. So that could be for environmental purposes, again for affordable housing. Some places use it for historic preservation, and those can be in or out of a target site. So tracking mechanisms for that type of thing. And then, of course, quantity and feasibility of affordable housing and other public benefits that are very important, but are difficult to deal with because of the complexity of understanding the situation on the ground. So, okay, so we'll take all of that aspirational aspect and then combine it with a dose of realism. So the dose of realism in this context comes from real estate financial feasibility, and we can look at things like market-based absorption, and instead of looking at specific sites and what their performance might be for a project in isolation, we can look at that in a broader context. And in just a few minutes, when Ian presents, he'll get into a lot more detail about the real estate and analysis part of this. Also looking at what kinds of subsidies and trade-offs are required to achieve certain policy goals. And then, of course, sometimes the largest dose of realism comes in when we work with stakeholders and the public, and they tell us that they don't like these ideas or they want to see things look a little differently. And then finally, I think it's really important to recognize that there's a change here that's occurring in terms of the use of 3D. It's not just for the analytical purposes. There's also a very strong qualitative component to using this information. So if you are designing in a sense of, in a geographic context that is somewhat realistic, then you're also starting to get to sense of place and the qualitative aspect of what makes communities great places to live in an intangible kind of way. Okay, so now we'll drill down again, and I'm going to get to a demo where we're going to see some of this live, which would be a lot more fun than the static slides. But if you'll bear with me for one more moment, we're going to look at this scale. And as Carlos was mentioning earlier, we deal with objects in UrbanCanvas as real-world objects. So you don't have to worry about points, lines, triangles, and all that good stuff that the GPU has to crunch and deal with. So in our world, buildings are real-world objects. So they have massing, they have floors, they have spaces, dwelling units, parking spaces, all that stuff. And you can interact with them at that level so that it's, and other people then you're communicating with also have the benefit of seeing the picture in terms of that kind of native language. So buildings can be visualized schematically and also increasingly realistically. They're easy to create and edit. And again, this is the labs portion, so not everything that you're going to see is available right this minute, but it's all in the pipeline at some point. And then finally, buildings can be assigned to scenarios and alternatives for comparative analysis and then round-tripping back to the regional scale modeling. Just a few other potential uses for these kinds of design and planning tools at this scale. So station area and transit corridor planning, neighborhood and district planning, sub-area planning, for example, a rezone of a central business district, campus and institutional master planning, which of course can dramatically change demands on infrastructure if a campus is expanding, whether it's a medical campus or a university. And then of course, coordination with comprehensive planning. And there are many aspects of environmental review that would also benefit from this type of interactivity. So, you know, I'm sure you're all familiar with this long list of things that are potential. But again, having the ability to work at both scales could be very powerful. Okay, so thank you for bearing with me on that. Now I'm going to switch over to our technology preview. And again, here's, if you want to send any comments, it's info@synthicity.com. Okay. Okay, so first off, I am looking at UrbanCanvas. This is an older prototype, so it's focusing on a few specific things. So again, Jason just showed what's coming in the pipeline in terms of the new look and feel, but this is really dedicated to the building scale stuff. So what you're looking at here is a regional view of Seattle. It's the Puget Sound Regional Council area, Seattle in the middle, Everett up here in the north, and Tacoma down here in the south. And of course, this is multi-scale. So you can see this sort of gray band here. That is the part of the light rail extension or the light rail line that runs to the south to the airport. So what we've done here is used some sample data from the city of Seattle, and I'm going to go ahead and just switch over into a traditional GIS view. So I'm going to turn on the parcels, turn off the buildings. You know, we could look at it like a standard GIS map of land use and see that it's a predominantly single-family neighborhood with some mixed use and multifamily area here and some commercial and whatnot. But that doesn't really tell you the whole story. So I'm going to turn those off, turn the background on, and go ahead and zoom in. Okay. So what we're looking at now is the platform for the station. And you can see very clearly that there's a lot of underutilized land around the station area. So a lot of opportunity here, at least from a physical standpoint. One big example here is this huge parcel that was, there were some buildings there that were taken down, and this was used as a construction laydown yard. This is in public ownership, and there's some possibility of using this as a catalyst site, for example. So what we want to do is think about what the design alternatives are for the station area, and then drill into the specifics for individual buildings. So what I'll do first is, using the scenario and the timeline tools that you've seen before, is switch over to scenario 1, which shows that this existing building, which had been built since the base year data was created, is now in effect. I'll just scroll forward one time step, which is 5 years to 2018, so that we can explore the potential feasibility of a catalyst project on that particular site. So I'm going to go ahead and zoom into this. Again, you're seeing this as a schematic view, but in the future we would support obviously different levels of realistic views as well. Okay, so with this particular building, what I'm going to do is simply look at starting its building info, and I realize that this is probably going to be a little bit difficult for you to see. Maybe you can see it. But what this gives you is an itemization of the space uses within the building, and the building's obviously colored by space use, so we have residential, we have office, retail, and we can track an arbitrary number of space uses, both above and below ground. And to Susan's question as well, it doesn't need to be just building in 3D space. It can also track surfaces like landscape, public plaza, surface parking, things like that. So this building is a dynamic object. If I go ahead and select it, I can zoom in on it and make changes to it. So for example, I might take one story and delete it. Did that work? Yes, it did work. Good. I'll delete another story just to show you. What was happening here in the building information panel is it's updating automatically. So it's constantly keeping track. You don't have to do any of that on your own. It's using whatever assumptions you put into it in terms of net to gross, or rather gross to net factors, number of square feet per parking space, and all the good kinds of like checklist numbers that you've got as urban planners and urban designers. Another thing we can do is add to this building. So I will simply say add stories. And let's just say that I want to explore creating 2 levels of structured parking above grade. So I will say that this is going to be parking, and it's going to be a 10-foot floor-to-floor height, 2 stories. Oh, well, I put them in the wrong place, but you get the picture. So in this case, we're going to have a car elevator to get above the office. It now added parking into the equation, and it made the necessary adjustments. And one thing that's really important about this, the 3D of this aspect of this, is that it can be responsive to the regulatory structures like zoning and whatnot, which is why there's a notch out of the building, because at the back side of this, there's an adjacent residential neighborhood, and they've cut out a swath of lower 40-foot height, whereas the rest of this has already been upzoned to 85 feet. Okay, so that's a quick look at some of the physicality of the building. So let's take a second to just talk about how you will be able to add buildings to this scene. So we anticipate there being 4 primary ways to do this. One would be by simply using a line drawing tool and literally just drawing a building footprint. You could do that, then it would become a building. You don't have to say it's a floor or anything like that. It just becomes a building. You can add floors, change space uses and whatnot. The second way that we anticipate is going to be really powerful and a lot of fun, and it is designed to be a building type editor. So you can go to a library and say, okay, I've got a C-shaped building, or a tower on a podium, or an L shape or an E shape or whatnot, and just drop it onto the site and have it scale to the parcels and whatnot, but always maintain a realistic architectural representation. So it wouldn't let you shrink the building beyond something that would actually be usable and so forth. The third way would be to import data from a standard GIS or CAD data source that has building footprints. And then the fourth way would be through procedural generation that takes attributes of the site and guesses what kind of building might actually fit well on that site. And so those things have different levels of complexity, so you'll see those phased in over time. But the whole intention of all of this stuff is to make it really easy to use. So now that I've got a look at this one particular building, I'm going to switch over to my financial analysis. And again, Ian's going to talk more about this in a second, so I won't get into any details here. But since this is probably going to be a project that's either affordable housing or include an affordable housing component, one thing that I want to do is look at the unit mix. So I can define the unit mix for the building using just standard numbers. I'm going to say how many studios, 1 bedrooms, 2 bedrooms as a percentage distribution in the building, and then I can say how much affordable housing may need to be provided at certain types of adjusted median income, and it will track all that for me and push all of those numbers into the Proforma analysis. So in this case, since this is probably going to require some sort of subsidy, the question is how much subsidy will this catalyst project require, and is that acceptable? So we can run those numbers and then use that as a means of interacting with stakeholders and landowners and so forth about that stuff. So once I've got some understanding of what an individual building looks like, I can also zoom back out and start looking at what this station area may look like as it develops over time. So this is just one alternative that has been vetted with the neighborhood. And so now we can do area takeoffs, not just of an individual building, but of several buildings as part of a single project or for the entire study area. And you can compare those side by side very easily. It's also possible to compare different scenarios. So here's an example of where we're looking at a public plaza and some landscape area, and what does that look like, and you can compare provision of public goods in that way. There's also the opportunity to look at special uses, for example, a community center, which the community, this is again that dose of realism, the community really wants a community center here, and clearly that would be a great asset for the neighborhood. But in terms of the real estate analysis, it needs to be considered very carefully because a program like that is expensive to build but doesn't generate any revenue, or likely doesn't generate revenue. So that doesn't mean that it can't work, but it just means that it needs to be considered carefully as part of the overall scheme for the area. Okay, so I think that's about all I wanted to say on that. Just a couple more things about the overall big picture. If I go back to looking here, I can change this over quickly to a different representation. So now what you're looking at are the buildings color, land use or zoning, one or the other. I can't remember which one this is. And we could simply move down the light rail line to where the next stop is, which I believe is here, and repeat the process and say, okay, let's define a new study area. Let's look at the context for this area. What are the development characteristics? Let's vision what the development might look like, and so forth. And so you could get the sense that we're starting to now integrate all of this design and planning into a single operational context, which makes all the information accessible to everyone else who's on the same system, and furthermore allows you to stop doing design and planning work in isolation for a specific site, but then step back and see what that big picture looks like at this station area, plus perhaps the other 15 station areas along that line. And then again, as I said at the beginning, you can use the outputs of this type of a design process or planning process as the inputs to an UrbanSim process, so that you're now closing the loop from regional to the local scale. So that's all I have from this Synthicity Labs presentation. I'd love to answer questions if you've got them.
So I was supposed to finish 5 minutes ago, so I'll be speaking in reverse and very quickly. Right. So I'm going to be talking about real estate development analytics. It's something that we've been approaching from a lot of different directions and kind of exciting. So let me very quickly keep going through my PowerPoint. The 3 different areas that we've been working in vary along these 2 dimensions with complexity and breadth. By complexity, I mean the sophistication of the analysis that we're doing on any given building. And by breadth, I mean we can actually analyze all the different building types on one parcel. So if you have zoning that is pyramidal, for instance, and you allow nuclear power plants, that might also allow everything else under the sun. We'll analyze the profitability of every development type on that parcel at the same time. So that's breadth. We've been working on private sector site evaluations for developer clients. We've been working on area plans, and you just saw a presentation of what an area plan looks like, and then working on a new beta of our UrbanSim Proforma model. So we like working in all 3 areas because they work synergistically. We're learning a lot from each area and applying it to the other. We're learning how to increase speed. And I like speed because in my world, speed means I get to do Monte Carlo simulation. And my background is in real estate investment, and I used to underwrite deals, and I like to do Monte Carlo, which means I need to run this model 1,000 times, and then I get a probability distribution of whether or not I should give this person money, right? That's where I want the developer model to head. So speed, very important. The other thing we were able to do is get a lot of fidelity out of it. We're actually getting into a lot of details. We're putting in a lot of cost lines, so to speak. So for every cost you can imagine, let's say that you want to increase parking requirements, you want to increase the amount of affordable housing, those things go in as cost lines, and you can tweak policies, and we run it 1,000 times and give you a different probability of development happening. So that's the goal. We're learning a lot on speed, learning a lot on the details. So I'll start with area plans since Rob just gave an overview of that. Let me just go ahead and skip. Mike gave a great introduction to proformas. Raise your hand again if you don't know what a proforma is. Now everyone does. So before you walked in yesterday, if you didn't know what a proforma was. Okay, few of you. You're going to see one. Here we go. So this is actually the Proforma. It's a highly simplified Proforma. I work in Excel. That's my coding. It's in Visual Basic. It's in Excel, and I hand it off to Fletcher, who integrates it and makes things really fast. So everything that you see here is pretty legible to you because it's simple inputs. These are variables that come from UrbanCanvas, what Rob was showing, and then they get passed over to an assumptions page. We input all the information that's relevant to a particular jurisdiction. These are relevant to Seattle, for instance, and you'll have things in here like what is the area median income. So if I have to multiply 30% of area median income times local area median income, I have that in the system. Once it goes through the assumptions, we do a bunch of calcs. It's just a page of calcs, and then that spits out cash flows. Now, Proforma is all about cash flows. This is about making money over time. So if you look at your life and you're going to earn, $50,000 a year over a 30-year period, you can calculate what that's worth to you today. That's exactly what a developer is doing. They're saying if I rent out 80 units at $800 a unit every month for the next 30 years, this is what it's worth to me today. And if I have to go buy that land for $20 million, it's worth negative $5 million to make that kind of money. If I have to buy that land for $5 million, I'm going to do it. I'm going to push ahead with that. So this is the way it works. You have a cash flow. It's a series of periods. So these could be months, quarters, years. It's just a flow of money, and we look at it across a spectrum of inputs. So there's sales cash flows, rental cash flows. There's the cash flows from taxes, which is a negative cash flow. There are cash flows from reversion, which means that I go to sell the property. All of these cash flows flow up into one number, the almighty NPV, the net present value. And if it's positive, that's good. If it's really big, that's better. As an underwriter at a bank, you're looking at the NPV and you're looking at the IRR, the internal rate of return, and you're looking to see if when you loan this person money at 6%, make sure that they're going to make a lot more money than that so that they can repay their loan. That's what it comes down to. All right, so that's the analysis that we would do for the local area plan. This is very specified, very well specified. It's a lot of inputs going into every building, how big they are, what type of housing it is, and we look at local market metrics and we spit out a number. This is going to lose money, it's going to make money. If it's going to lose money, that means someone's going to have to come in and provide a subsidy if you want that plan to work. Cool? All right. Make money, you don't have to subsidize it. Cooler? Yeah. So that's the point of that whole tool. You just calculate the number at the end, and positive is better. So the other area that we're going into is private sector. Private sector development is also pretty simple. As a former residential real estate investor, I can tell you life is a lot easier than in politics because your only thing is to make money, right? Profit motive. You are looking to maximize that number at the end. So we are looking at this and we're approaching this for our private sector clients and for UrbanSim as if we're trying to maximize profit. And this is the process that a developer goes through according to ULI. Basically what I did when I was investing. At any point in this process, any of these red arrows here, you're running the Proforma. You're running it again and again and again, and as you get further down here, the Proforma gets bigger and bigger and bigger because you have more knowledge, more inputs. So at the very beginning, when you're doing site selection, you're doing what's called a pencil out. Anybody ever heard of a pencil out before? Yeah. Pencil out is what you do on the back of a napkin, and it's basically approximate revenues minus approximate costs. Is it positive or negative? Once you get down to entitlement, that's where you're getting your zoning changed and your variances. You have very specific numbers. This is where you go to the Mayor's Office of Housing in San Francisco and you ask them for exactly what the in lieu fees are. You go over to the Public Works Department and you say, what's the sewer fee for 80 units or 79 units? I can't decide which one I'm going to build. And they tell you a number and you put it in. So your Proforma is getting better and better. And at any time, if your Proforma says it's going to be really bad, you just stop. That's the trash cans. All right, developers just walk away. And we get to model that in UrbanSim, which is fun, right? We only build the things that are profitable. Everybody else walks away. So for our private sector clients, let me just show you what we do, basically. They send us a Proforma. This is a pretty recent one. This is got cost assumptions and details from the 30th of July. I blacked out. You can't see who this is. And I'll just show you. This is their material. So it's a page of numbers on the front, but behind that is a lot of detail. You have the cash flows. You have the detailed cash flow. You have the monthly cost. You have the architectural engineering, the legal fees, municipal fees, marketing fees, operating expenses, all of these things. So what I do is I go through and I do something called generalizing. I made up that term. No one else does this. I try to generalize this pro forma. I go to the developer and I say, all right, you gave me the pro forma for an 80-unit building. Work with me to figure out what it would be if that building were 5 units or if it were 150 units. Tell me what it would be like if you built that with underground parking versus above ground parking, structured parking. Tell me what it would be like if you put a pool. You didn't. And we then use, you can see all the places that I've marked red are places that I've had to change the pro forma to generalize it, so that what I can do next, well, what Fletcher can do really well, is we can run through a lot of options very quickly. The result for a client looks like, let's see, looks like this. So we give them a map. So this is the Bay Area. This is San Francisco in particular. This client is a multifamily developer looking to build condos somewhere in San Francisco, and they want to find sites. San Francisco is pretty built out. It's hard to find sites. This is going to help them. So if you remember, that's the first bucket of that chain is site selection. So we zoom in here. What we've done is we've run the pro forma. Please come back. Yeah. Oh. This is fun. Live demo. So what we do is we run the pro forma the equivalent of about 850 million times at a lot of different size buildings, a lot of different parking attributes, and we try to keep it as realistic as possible with costs that are localized so that when we get an output from the pro forma, it's pretty accurate. So if the developer says, I think that I could sell condos at $900 a square foot on land zone multifamily, and zoom into all the parcels in San Francisco zone multifamily, you'll see a lot of red. Red means that it's not going to make money for this developer to build there. Yellow parcels are those where they might make some money, but it's touch and go. A bank's probably not going to give them money. Green is where they should go and buy property and see if they can get it for a good price. So you can see there's not much green at $900 a square foot. But if we zoom in and we click on one, the developer model has runs pro formas, and it's found the most profitable option. The most profitable option here is going to give this person a return on their equity, so the amount of cash they put in, of 175%. They're going to build 28 units, we estimate. It'll be a 32,000 square foot building on a 12,000 square foot parcel, so an FAR of about 3. Probably a 4 or 5 story building. Probably still stick construction, not going all the way to concrete construction, so it's a little cheaper, a little bit more profitable. And you can see that they were going to have to pay a little under $1 million for this parcel. Just next door, we have another parcel, and you say, well, how could a parcel next door be red? Well, on this one, the upper one there, you can see if they were to put their money into this, they would lose 57% of it, building the most profitable option, which would be building 6 units on a small parcel that they were going to have to pay $3 million for. Right? So they're going to have to buy this parcel for $3 million, is our estimate. So it's not a good deal for them. So that's why they wouldn't develop there. So we've provided this to our private clients, and then I decided to have fun with it and do some analysis that I thought would be interesting for you guys. I'm kind of a TOD dork. So I looked at the outputs of condo development using this developer's Proforma in San Francisco. And you can see that the different modes here, this is all the number of units that would be profitable, the number of buildings that are profitable, and the units within them, within a quarter mile in dark blue, within a half mile, quarter mile to a half mile in the light blue. And you can see that it varies by the type of transit. This is kind of analysis you can have fun with a Proforma model like this. Now, what gets really interesting is when we look at the density that can occur close to transit. This might be unexpected because what this is saying is that around proposed BRT stations in San Francisco, you get really high density condo, profitable condo options close to BRT, but lower density further away. Light rail, lowest density of all. And BART, doesn't matter if you're a quarter or a half mile away, you're getting the same density of development. Now this is just what a Proforma tells us. It's just fun outputs from a Proforma. The other really fun thing that I found was that sales price of the local area is not predictive of the amount of allowed and feasible building options. So each one of these dots here represents, the scatter plot is of stations. On the X is their residential sales prices average, and the millions of square feet that could be profitable. All right, so what we're finding here is that sales price isn't necessarily correlated with the amount of development that would be feasible. Why is that? Well, probably because in high sales price locations, land is really expensive. And in high price locations, probably there's already a lot on the ground. The other fun thing is that when you go in an up zone in San Francisco, this looks like it might be the result when you're looking at condo development. Up zone station areas are only marginally more likely to have feasible projects in them. I thought that was pretty fun and unexpected. And the other really fun thing is if we zoom into this area down here, you start to see that there's a lot above the sort of one-to-one line here, which means that we're tearing down a lot to build in some places. So the zoning is low, the demand is high, and we're tearing out buildings that exist to build anew. So in dark green are the number of units that people are tearing down and replacing because it's so profitable to build new stuff here at bigger and better, according to this Proforma. And this is just the number of units within a half mile of these different types of transit. So that's fun with Proforma outputs. The other thing that we're doing is obviously UrbanSim. So we're taking all this knowledge and we're applying it to UrbanSim. We're coming with the beta, and you can see that I've moved it to the left on complexity. You saw how complex the Proformas were that developers are using. You know, if they go out to lunch with a banker, they put it in their Proforma. It's a cost. But we don't need that to predict UrbanSim outputs. We can take a lot of that noise out, and when we take the noise out, we can run Proformas faster. When we can run them faster, we can do things like Monte Carlo simulation. So here's an example of what we're doing with our new UrbanSim spot analysis model, which is a simplified Proforma. We take market metrics. This is a layer. You apply also the limitations of local public policies, and you then add to that development feasibility, which is coming from the Proforma model. And when you stack those three on top of each other, you end up with a map of where development is feasible in the city of San Francisco. And from that, you know, UrbanSim can, and this is assuming obviously a price coming from UrbanSim. So that's where Vanegas' work is really important. And from this, you can select your development options and change your buildings table and update that year's development projects. So that's, in a nutshell, how Proforma is working today, and how we're going to be improving it is keep working.
Thank you.
Yeah.
All right, there's my very visual presentation. All right, it's an outline. And I'm going to talk in turn about 3 different parts, as you see here. The first one, all of these things, we're still fishing for the right naming conventions and terminology for them. But first one we're loosely defining or referring to as the urban information system. And you've heard repeated descriptions of this cloud-based client-server architecture in which we've got a lot of data that we're pulling down from tile servers and our PostGIS database and so forth. A lot of information is being stored not on the user's computer, but off-site. It could be in servers sitting inside the offices of your MPO, or it could be sitting on an Amazon cloud server or one at Synthicity. That's not really the main point. The point is really that there is a distributed information system that contains not just a cluster of assets that include parcels and buildings and streets and transit lines and roads and so forth, but 3D objects, terrain, zoning, general plans, all that information is being assembled with household data, with employment data, and fused into what you saw Fletcher describe and show with the accessibility queries into an incredibly fast and responsive interactive system. So what we're beginning to think about is, first and foremost, that the biggest asset here is all of that information fused and a distributed access system for sharing that information. So we're thinking of this urban information system as something that might be sponsored by the MPO. It might be shared between the MPO and major jurisdictions. If the MPO isn't involved, in some cases, maybe the major city steps in and participates and starts an activity in a region that grows into a regional project. What we would love to see is a move towards open data and shared data so that the kind of workflows that you all have to wrestle with in terms of coordinating between the regional planning efforts and municipal planning efforts and corridor and site level plans can be seamless, can actually work really, really smoothly. So as we're thinking about this, we're looking at trying to develop a platform that provides a subscription basis that we find some way to make happen. It doesn't happen by magic. It happens with a lot of work and taking annual updates of data, loading it into a system, integrating the data, and providing efficient and visually compelling and effective user interfaces to engage with, query, edit, and analyze that data. So there are 3 options we're evaluating here and exploring. I think as in each of your regions, you're thinking about whether or not this makes sense. In your case, we'll want to have discussions about what option makes more sense in your case, and whether there's some collaborative effort that could be done between the regional agencies and the jurisdictions. So I wanted to start with that to set the stage, because the rest of what I'm describing requires that we create that urban information system and maintain it. So this is the foundation layer for everything else, and it's all the data assets and infrastructure to share it. So now I'll turn to UrbanSim, and I'm going to talk about 2 different parts of that ecosystem. The first is our consulting support. And so what we're proposing to do here is provide consulting support for MPOs principally, but also other kinds of users. Some of whom are adopting UrbanSim for the first time, and so they need help as we're working with Madison County and Mr. Cog right now, and Denver, Dr. Cog, on trying to get their data assembled, cleaned, integrated, specify models, working closely with them to learn about what's important in that region, develop a model estimation set that gives a good starting point, teach them how to use those model estimation tools so they can continue to tinker and add variables and modify those models, go through a calibration process, assemble hopefully enough historical data to do some level of validation longitudinally, and and then start testing the model system, get it tied to the travel model, start running simulations over 30 years, visualizing results, and so forth. And then, you know, roll out the training wheels and then gradually take them off so that it's easy for users to generate scenarios and run them totally on their own and manage and maintain the specification of the model system. So that's the typical use case for a new user, and we think it typically will take us now, instead of the many years it has taken in some cases in the past, we're starting to see workflows that are getting us through the process much more efficiently now, in 12 to 18 months, depending on the size and complexity of the region and the quality of the data. There are many UrbanSim users already out there that are using an earlier version of the system or some variant, and you know, for those that want to upgrade to the current work that we've been showing, we think it would be a much shorter workflow, obviously, because you've already got your data in hand, you've got procedures in hand, and we think we can shorten that to probably closer to the short end of a 3 to 6 month schedule. And then we've also heard from some of you that maybe you hit a few bumps in the road during the operational planning process, and it would have been helpful perhaps to have access to ongoing support during that process to help solve problems and add functionality in some cases along the way. So our strategy here is to think about including with any of these consulting projects a subscription to what I'm going to describe as UrbanCanvas Modeler. And think of that as UrbanCanvas with the interactive UrbanSim that you saw Fletcher describe embedded in it, so that you've got access to all of that interactivity of UrbanSim and UrbanCanvas all under the same platform. And so our strategy also would be to provide earlier access to any of you that we're working with to UrbanCanvas and to the interactive UrbanSim. Hard to figure out exactly what the cost is without looking at the details of you know, what the size of the data set is, how many counties are we having to wrestle with, how incomplete is the data, how much work has to be done, basically. So these are things that have to be costed out with some knowledge of the local context and what your needs are. In terms of the software itself, the new platform that we showed yesterday that's based on the Pandas libraries and various other libraries and is not built on top of Opus, but is intended to be much more interactive, much more directly accessible to you. We're anticipating a transition period, and we think it's roughly going to take through the rest of this year and into 2014 to figure out exactly how to fully transition from a lot of infrastructure that's done great service to us and many of you into a more full usage of the new platform. As Fletcher described, we're putting this into a Git repository right now. It's a private repository, and our preliminary thinking about this is keeping in mind that we're trying to actually build the system and maintain it, and we have staff that's required to do that, and we have to actually help them pay rent every month. Have some advantage for users that actually have a consulting project with us or a subscription to the software to be able to then provide access to the Git repository on an ongoing basis. And for others that are willing to be a little more patient, we'll do installers that we might release once a year. We'll bundle up the best of the enhancements cumulatively over the year, and then provide those with a standard GPL license. There are some parts of the functionality that we've shown in the last 2 days that after a lot, and I can't emphasize that enough, a lot of internal debates and discussions, we've decided really we have to protect the code to keep it from simply being replicated by commercial companies, none of which I need to mention by name. But the accessibility engine, which was generating those incredibly fast queries that you saw yesterday, the advanced Proforma model, and we're still working on the nuances of exactly how we're going to break that out. But A lot of the more sophisticated parts of the Proforma model, the more detailed aspects of it, we'll probably also use a proprietary license for. And then some of the geometric calculations to do parcel subdivision and aggregation, which have come up in the topics of conversation today. We'll also have heavy dependence on the geometric libraries that are behind UrbanCanvas. And those will also obviously be in C++, OpenGL code, and protected with a proprietary license. Our intent is not to make these inaccessible or difficult to get or ridiculously expensive, but we do have to be able to protect the intellectual property and make sure that we can stay solvent. So that's the basic plan. We would have some transition period again between the current Opus-based UrbanSim and the new interactive UrbanSim, and we may want to keep a version of the current Opus code online, active, available by Subversion as a community version. But I think most people would find some advantages to the much faster and simpler new version. And so the last part of this is UrbanCanvas, and I think by now you've probably gotten a clearer picture that it's a large toolkit. It's very modular, and we can essentially design different interfaces to it, different skins, if you will, to tailor it, customize it, as Jason was showing earlier this afternoon, for different use cases and different users. So the first one of these I'll describe as UrbanCanvas Modeler, and that's the bundling of interactive UrbanSim with UrbanCanvas. So the feature set that we're looking at here, and you'll see various parts of this repeated in other versions, and this is very open to feedback. So if there's some key feature missing here, we would want to discuss that. So all the tile-served data, the map layers, the terrain, would be automatically part of this. Being able to view all the model inputs and outputs, being able to compute indicators on any geography from the parcel, the building, street node, zones, census blocks, cities, whatever geography you might find useful. Being able to not only view the base year data, but edit that data, clean it up, do quality control on it. Edit development projects, as you saw Connor demonstrate. Create all the inputs to the scenario so that you can immediately then launch a simulation, watch the simulation as you're monitoring indicators as it's running, or looking at buildings that are being built over the course of the simulation. All this would embed the IPython notebook approach that you saw as one view into the modeling, and we'll combine that with more of a graphical interface, menu-based interface to already specified models. So the things that you most frequently want to be able to access and you don't want to have to play with the code, you can work with the graphical interface. So I recognize that the world is full of GUI lovers and script and code lovers, so we'll accommodate both views of the system. So the last point on this bullet list here is the idea of being able to author or curate views of the data. So let's say that you have generated, as was done in all of your cases, different scenarios. You've simulated them, you've generated results from them, and now you want to distribute them for review or for just public consumption once the modeling process is done. So in the same way that Jason was describing being able to customize views, we could allow users to curate in UrbanCanvas what I'll refer to for the moment as galleries of indicators and views of the data with different scenarios and the time sliders involved, so that whoever your stakeholders are, you could distribute a copy of what's the last item on the list here, an UrbanCanvas viewer. And that is something they could use to load up on their computer, look at the data, interact with it under the controlled environment that you've created. We may also complement that with web-based viewers, so web-based and UrbanCanvas viewers for disseminating results and, as I say, curating and managing what data you expose and how you expose it. recognizing that some of the data that's going into your models is proprietary or confidential, and you can't disclose that information. The target users for this are basically, like many of you in the room, land use and transportation modelers, many of you at NPOs or in larger cities, possibly counties, and any number of other users that would be interested in doing urban modeling. Certainly a lot in the research community as well. And our research plans for this, I think you've seen in the course of the last 2 days a beta version. So we have a beta version alive and well, and we have 3 MPOs, 2 of them represented here today, and Denver unfortunately wasn't able to come, that are actively using it, kicking the tires, giving us feedback, very valuable feedback, I might add, on what's working well, what's not working so well, and what features are needed to make it work more effectively for them. We're thinking of the approach for pricing on this to be based on a subscription, so that we make it something that we annually refresh, we continually add in new features, and we have a more predictable revenue stream to support the activity. We'll try to differentiate pricing. If we're dealing with those nasty real estate developers, we might charge them a lot more. And those wonderful academics, we might charge them a lot less, etc. So we'll be working out the details on all of that. We talked yesterday, and you heard it in a couple of the presentations yesterday, the idea that there is a need not only to do modeling on a regional basis, but also sketch planning and visioning. And I think it's pretty easy for you to see that with the technology platform we've got, it's not difficult to add in interactive design using place types. You saw an example of that in Carlos's presentation, where you can simply paint with different place types in the same kind of idea, but much more interactive, as in other existing sketch planning tools, and use that to guide the conversation towards visions and targets, but then in the very same platform be able to do modeling and reality testing. And I think by closing the gap between visioning and sketch planning on the one hand and reality testing and modeling on the other hand, looking at what kind of strategies and tools and policies could help us get to visions, it can make this a much more coherent conversation to have. So the other kind of features here are essentially the same as the UrbanCanvas modeler platform, but in this case, instead of running UrbanSim, you might be running simpler allocation methods that are allocating to places that you've upzoned or changed the development types for. The next element is the what I'm calling the area planner. You can think of it as a more localized version of the sketch planner. This is more along the lines of what Rob was showing with the transit-oriented development scale, site scale work, where there's a lot more interactive design at the building level, even sub-building level, which is quite detailed. Certainly campuses or transit-oriented developments would be good examples of that. And a lot more attention in that case to detailed design, not only of the buildings, but of streetscapes and how that works in terms of connectivity, profiles of streets, and so forth. So again, a lot of shared infrastructure between this and the other builds or ways of distributing UrbanCanvas, but the use case is more localized in this case. And then the target users are many of the same people, but more likely to involve urban designers and planners, possibly real estate developers at this level of detail as well. So in each of these cases for different builds of UrbanCanvas, we're looking at a subscription service for the rollout strategy. We're trying to decide at this point, given our limited capacity, how high a priority should be our moving forward of the area planning rollout, how much interest is there in the regional sketch planning rollout, and that will help us prioritize essentially our not infinite capacity. Seems infinite at times, but it's not. And then finally, the viewer, which I've already made some references to, is the idea that without a capacity to edit, you could distribute to your constituents ways to view the data, interact with it, query it, and potentially the ability to comment. So if you're the MPO and you've got preliminary draft forecast and you're going out to your jurisdictions with those, you could potentially have a deployment of UrbanCanvas to let them view it and then identify areas they think are excessively optimistic or pessimistic and describe the nature of what their concern is and tag that geographically to specific areas. So a very convenient way to facilitate that information feedback. At the jurisdictional level, it might be a proposed project and getting community input about different alternatives for that project and what kind of concerns there are. And again, those could be filling out a survey or they could be putting in comments. And those could be centrally accumulated, of course, queried, summarized, and reported. So for the viewer, the target audience would be not so much modelers or really technical people, but policymakers, advocates of different kinds, individual citizens in a community, and businesses as well. And you may think of other stakeholders, but that pretty much incorporates most people I can think of. So for this, we've intended to try to finish up. This is actually the least feature-rich version. So it's something that we think we can complete during this calendar year. And it would support and complement each of these other use cases in which someone can actually curate and create data and views that the viewer would then be able to access. Another aspect of the viewer that we think might be valuable is to be able to potentially brand or label the viewer with the name or logo of the jurisdiction or of the MPO. So as you're delivering data out, you're getting also good feedback and accolades for a great service you're providing the community. So that's a quick spin through what we're doing in terms of our thinking at this point. And I'd really like to just facilitate a conversation about these things and get feedback, get your recommendations, priorities. If we missed some key features that you're interested in, I'd like to hear about that as well. So I think with that, I'm going to close my comments and just open it up for Q&A, and then we'll close the session and the workshop. It's been a pretty packed 2 days. You've had a lot of information thrown at you from us, and I think we've heard a lot of really great feedback from different users that are doing amazing things on their own turf. So with that, let me close and just open it up for questions.